Alright, so have a look at these. Find the number of subsets of 1, 2, 3, 4, whatever, all the way up to n that do not contain consecutive terms. So, like, if it contains 2, it can't contain 1 or 3. Okay. I think this is a nice problem. This is the problem Alexa suggested last week. Um, she had a good way of doing it, but she didn't. I didn't ask her for it, but maybe it's the same way. So, I think for us, we want to try small values of n. And what did you get for the smaller values? You remember? So if n is 3, so let's call this answer like the let's call the answer an. Yeah. So if n is 3, an is 5. Yeah. What other values did you get?
And what would A equals 4, then the value is 8.
8. Did you get n equals 2?
0? No. 3.
3, yeah. 5. 13. Okay. Did you notice a pattern? So you can see from this that the 3 plus 5 equals 8. 8 plus 5 is 13. Yeah? So have you heard of the Fibonacci sequence? Okay. I guess if you haven't heard of the Fibonacci sequence, this question would be a little bit weirder because like you wouldn't be able to say the answer maybe nicely. Yeah. Whereas if you have a name for this sequence, then you can say this is the answer is this sequence, and then it sounds more like an answer. Okay. Um, but how do you prove that it's this sequence? Yeah. Well, to prove it's this sequence, you just need to know the starting values, which you've already got here. Yeah. And you need to show that the next value is gotten by adding up the previous two values. Okay. And so, so, um, yeah, so sometimes you don't need to know the name of the sequence. Sometimes it doesn't ask for all n. Sometimes it just asks for like n is 15 or something. And so then you can just find the number. Okay, and then knowing it's the previous ones gets you the sum pretty quickly. So so this is called, I guess, a recurrence relation or something. See, because what you can do is if you look at the subsets, you can consider the ones that contain 1, yeah, or don't contain 1, yeah, yeah. So they're mutually exclusive. If it contains 1, right, then it can't have 2, yeah? There can only be 3 onwards, okay? But it's the same condition for 3 to n, um, which is the same as also from 1 to n minus 2. So then the number of this is a n minus 2. That makes sense? Okay. If it doesn't have 1, okay, then you're really just doing it from 2 to n, right? Which is the same as doing it from 1 to n minus 1. So then this is a n minus 1. So then the total a n is equal to a n minus 2 plus a n minus 1. And so therefore, um, it's going to be a Fibonacci kind of sequence. That makes sense? Yep. Okay. Hopefully viewers like this problem. And they subscribe.